Good morning and once again welcome to my YouTube channel, Pearson at Excel International Math by Mr. Kamoto. And in this video, I want us to look at example 4 of pure mathematical integration. And we have just understood the general formula for the volume of, or rather when a region is rotated through x-axis or about x-axis through 2 pi degrees. And in this particular example, a curve is represented by the parameter equation is represented probably by parametric represented by parametric equations. X is equals to 2t and y is equals to t squared. Find the volume generated when the curve is rotated about the x-axis from when the volume generated when the curve is rotated about the x-axis from 2t is equals to 2 to t is equals to 4. And it goes without saying, we know the general formula for the volume is pi integrate y squared dx. And our curve is not in this setup. It doesn't fit here. It is all in terms of t. And you can see the general formula is in terms of x. So we have to change and let our curve fit in this particular formula. And of course, the easiest way and what we saw is to do away with the x and of course bring in the t. How did we find out that? We said that we know x is equals to 2t, because the first thing we must do is we must substitute dx with something to do with dt, and we saw now dx dt according to us is 2. And definitely if you cross multiply, you'll find that our dx is equal to 2 dt, and that is one piece of information that is going to be very crucial in this particular question. Now that we have seen our dx and y is already in terms of t, then we can say the volume is pi, the integral now of y squared, which is t squared. Then we bring in the dx, which is 2 dt. And what we need to do is, now this is the equation we are supposed to integrate, and we can already see within it we have 2, which is a constant, so we can rearrange that even as we bring in now the limit, because everything now is fitting into t, so we can now bring in the limit of t. It's going to be 2 pi, because 2 is constant, integrate from 2 to 4, the equation of t squared dt, and now we can finalize and have it like 2 pi, the integral from 2 to 4 of t raised to power 4 dt, because this one has to be opened up. And what we have is now a direct integration, which is 2 pi open bracket t raised to power 5 over 5 close bracket, and then we bring in the limits. Substituting the two limits, we have something that looks like 2 pi. We have 4 raised to power 5. We can 4 raised to power 5 over 5. By the way, we can also bring in this 5 at that particular point, because just dividing, so it can divide the first, so that we can free the terms that are operating each other from the denominator. 4 raised to the power 5 minus 2 raised to the power 5. And I want to just work it out and find out 4 raised to the power 5 minus 2 raised to the power 5, 4 raised to the power 5 minus 2 raised to the power 5. It's 992 times 2 pi, which is, this is now times 2, we have 1984. It's going to be 1984 pi everything over 5. 1984 pi everything divided by 5. And that is just like it. We would have also worked with 5 under each one of these, and let's see, but it's as easy as that. So that is the end of the story. That's the end of the example 4. Please get to my YouTube channel, subscribe and share widely, and let's see how we can help each other. All right.